is to sketch our velocity time graph. So here I've got three graphs. I'm going to talk about which one's which. Obviously we've got time. Where does time always go? X-axis. So when I'm filling this out, I'd write time down here, and I'd put my units, which is seconds, there. For my velocity, where does it go? Y-axis, okay. And obviously, too far. Obviously for that, when it decides to fire up, we're on our side, we need a unit for that, meters per second. Because I haven't got room, I haven't got a title, but normally you'd put velocity first time. Happy with that? Or velocity time graph. Quite simply here, 0, 0, 110, 220, 330. What should that represent? Straight line. Mine won't. Why not? Hand drawn, and I didn't measure everything out. Okay, I'm going to change it so it does look a bit more kind. Very good. What does that represent? That represents a scenario we're probably familiar with. I've chosen a number for acceleration for a reason. What's our acceleration? Yep.
Acceleration is change in velocity over time.
Change in velocity over change in time. What's another? How could I represent that on this graph? What is that?
Gradient.
Gradient. So m equals, you could write y2 minus y1 over x2 minus x1, rise over run, whatever you would like. If I pick 2 points, any 2 points in that graph, give me one of the points. Kate, give me a point.
330.
330, and give me another point, Will. 10, 1. All right. 30 minus 10 is? 3 minus 1 is? All right, let's try the way. 10 minus 30. Negative 20 divided by 1 minus 3. What's negative 20 divided by negative 2? 10. Was there a point in that graph where my gradient changed? So would that gradient apply for the entire section?
Yes.
I've just done my acceleration time graph. What am I missing? Title? Yep. What else am I missing? Axis. So I've got time down the bottom. And my unit for acceleration? Meters per second squared. I can tell you that by looking at that graph. How could I tell you that? What's the unit for my y value?
Meters per second.
What's my unit for my time value? How do I write meters per second divided by seconds? Meters per second divided by our unit for time, which is seconds. Happy with that?
Yeah.
So I'll just go through that again. My gradient, my y-axis is meters per second. My x-axis is seconds. I've got y over x, which means I've got meters per second divided by seconds, which can be written as meters per second or meters per second squared. Keep your eyes on the units. It's a massive hint. If you know the unit for acceleration, you already know the equation. Displacement